Hello, students, and welcome to the first episode of MSI, Math Scene Investigators. We're going to be taking our notes on page 33 in our composition book, and this is section 4.3, Function or Not. We have some scenes from this math investigation that's going on right now, and we need to use our magnifying glass to see if these scenes represent a function or not. And you might be asking yourself, well, Mr. Cohens, how do I know if it's a function or not? And I'm going to answer that question because we have to have our data in order to tell if it's a function. So the first thing that you need to know about a function is a function has nothing in the x value that repeats. Write that down. A function has nothing in the x value that repeats. No x's can repeat in the relationship in order for it to be a function. So let's check this out. I've got a function 1, 4, 2, 5, 3, 6, and 4, 7. Let's graph those points. 1, 4, 2, 5, 3, 6, and 4, 7. I graphed it. It looks like it could be a line. Does anything in the x repeat? No. So this is yes, it is a function. I'm going to switch colors because you know when we do investigations we like to use multiple colors, and I'm going to use red. And we are going to switch the camera and we're going to look at my other set of data. And we now have 5 points, and we are wondering, is this a function? And I have the wrong color marker, so now, is this a function? I have 0, 3, 5, 1, 2, 3, 5, 4, and negative 2, 8. Does anything in the x value repeat? I repeat. Does anything in the x value repeat? Well, if we use our magnifying glasses, we can look down here and we say, there's a 5 in the x value that repeats. We have this 5x and this 5x. So is this a function? No, not a function. This is not a function because we have something in the x value that repeats. Let's graph these, and I'm going to show you one other way. 0, 3, 5, negative 1, 1, 2, 3, 4, 5, negative 1, 2, 3, 1, 2, 1, 2, 3, 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, and negative 2, 8, 2, 3, 4, 5, 6, 7, 8. We see all of our purple dots on our graph. Now they don't even form a line. That has nothing to do with whether it's a function or not. We just need to see if anything in the x value repeats. Now you might be saying to yourself, but Mr. Cohens, the 3 repeats in the y. That doesn't matter either. It doesn't matter if anything repeats in the y. It only matters if something repeats in the x value. Now we have this other little test that we can use, and that can only be used on a graph, and it's called the vertical line test. The vertical line test says that if I can draw a vertical line anywhere on my graph and pass through more than one point, then I do not have a function. So if we look, I can draw a vertical line here, 1 point, a vertical line, 1 point, a vertical line, 1 point. But if I draw a vertical line right here, I pass through 2 points. So in this case, my vertical line test tells me that it is not a function, just like we figured out over there. Well, let's look at the brown example. On my brown line here, if I drew a vertical line, 1 point, vertical line, 1 point, vertical line passes through 1 point, 1, 1, 1. I don't have any vertical lines that would pass through more than one brown point. So that proves again that this brown table here is a function. To wrap it up on our first episode of MSI, Math Scene Investigations, to find a function, check the x's. If anything in the x repeats, it's not a function. If nothing in the x repeats, it's a function. We have solved the case.